Hello, everyone. This is Joao from Cartesi, and we're here back with another episode of I Builder 4 a.m. This time with me, I have Jag, core developer from Syscoin, and he's going to give us a breakthrough about Syscoin and all its amazing ideas and what they are providing the ecosystem with, right? So, hello, how are you, Jag?
Hey, Joao, how are you? Good.
I'm good.
Thanks for having
Great.
us.
Thank you for being here, man. The first thing I would like to know, joining your docs, exploring your webpage, I came onto this picture right here that kind of explains like what's in development and what's the take from Syscoin as a whole. Can you give us a walkthrough about what is Syscoin, what do you guys do, and what are the plans things you're cooking right now?
Yeah, I guess a little bit of the philosophy is that we started from the Bitcoin side of things. So we merge mine, we share the security with Bitcoin miners, and then we do modular blockchain on top. So taking the best of the modular smart contract world, DA, rollups, all those sort of things, and applying it to shared security with Bitcoin miners, right? So you get the Bitcoin mining security, the hash rate, the difficulty, and then you got the DA and the scale ups and edge computing and ZK and optimistic rollups on top. You have a separate stack. You have the UTXO stack, and then you have the EVM stack, and they both work together in one chain. As far as I know, we're the only people doing that. There's a lot of people that try to mix it all together and create complications, but we like to keep them separate because they have separate code bases and stacks and upstream merges that need to be always thought about. With thousands of developers merging code all over the place, you need to keep them consistent and safe and secure. So we kept those different and have a bridge in between the UTXO and the EVM layer in the protocol. That gives us a layer one that allows us to have great settlement security and not necessarily fast. It's not necessarily high throughput at the base layer, but it does give the ability to create high throughput computing through our hash-based data availability layer, and then smart contract settlement. So you can do anything that you could do on any other smart contract platform and settle your rollups and then have them as scalable as anywhere else in the world. And it will be as secure using the philosophy of Bitcoin. For example, the data availability is a hash-based system. It's not a splitting up the data and sharding and doing proof of stake. It's rather every node verifies the data, stores it, deletes it after finality, and the system can rely on just the hash. So, for example, if you're going to do a ZK proof, this is like a realization we've made recently that you could do a ZK proof of a validity proof of the whole chain and encapsulate the data within it. Typically, you can't do that with other designs because the data is split up across nodes, and you can't get a verifiable proof that the data exists everywhere. You just get a probabilistic proof that maybe some nodes have attested that the data existed. So by using the Bitcoin philosophy, we could essentially apply the only trust myself, not trust anyone else, and apply it to ZK principles and create a more holistic design that allows us to scale but keeps our roots and philosophy into the Bitcoin side.
Isn't there a huge difficulty into proving such a huge amount of data, or don't you think the amount of data is that large? What's the mechanism to go around this?
Yeah, I guess there's throughput concerns on the data availability itself, which is, so let's say, 0.5 megabyte a second. We feel that it's sufficient for using the base layer, and there doesn't need to be an infinite amount of throughput for data on layer one, we feel, because there is a cap constraint, a resource constraint on using these finite resources, and if they were dynamic, the economics would also falter as well. So it would become essentially free, and the node running a full node for that system becomes exponentially more expensive, and therefore you end up getting centralized. It goes super cheap, almost like a peg that breaks. It will never come back. So you have to sort of parameterize it and look at it from the perspective of if everyone and every bot was using the system, could they settle on this frequently enough to be able to make it convenient to use 100% of the security? Not necessarily let me do all the DEX swaps, let me do all of the IoT transactions and use the base security, because there would be other DA services, other data services on the networks that have probabilistic security and not full layer one, deterministic security. And those would fill in the gaps for the throughput needed for other things. But for the base cases of settling, doing high value transfers, doing daily transfers, maybe point of sale, getting that sort of throughput, which is 20, 30,000 TPS or something like that, you could definitely get it with layer one and pay the rent to the layer one. Getting it above and beyond that, doing real-time streaming and stuff like that, you could definitely use external services and DA services that have maybe shared security with some other asset like Bitcoin or with slashability in mind. And that's how we think about it. Is there are facets in this. There's the layer one security, then there's all else. The all else will fill in the gaps instead of trying to push everything and say we're going to solve everything at the layer one and make it as abundant as needed. I think that's the wrong approach, because you have finite resources. That's a zero-sum game. You cannot squeeze everything into one base. If you do, then you will have trade-offs and you'll end up either becoming insecure or the system just won't be used because it'll be too either not expensive or no one cares enough because it doesn't have the right security model applied to it. Ethereum sort of had this issue. It became too expensive, so people started doing rollups, and then as the rollups came, the DA became too expensive, so they started using external DA, and now they're thinking, how do we enshrine those back and make them pay the fee, right? And on the other hand, they have a DA roadmap that wants to exponentially keep scaling, keep adding more throughput over time, which would affect the profitability of the validators, because people are paying less rent because there's more data and requires nodes to beef up their servers. So there needs to be some inflection point where we feel, if you parameterize it around 0.5 megabyte a second, it gives us enough throughput for now to be able to find that sweet spot of security versus having the modular layers take care of other DA services. But in terms of doing validity proofs with large systems, like a whole layer one system, and providing DA for that, or providing a ZK proof of that, what I meant there was essentially, how Ethereum is moving towards a recursive ZK proof system at the base, right? BitVM, for example, using a light client to prove bridging between Bitcoin and other systems, you need a ZK proof to prove that your Bitcoin is burnt on side systems before you bring your Bitcoin back. Those ZK proofs can get quite large, but recursively they get crunched into smaller and smaller amounts. What I meant simply there is our layer one just uses a hash-based DA service, so it doesn't need a whole bunch of cryptographic plumbing to in the ZK proof. It's basically just a hash of a few megabytes that goes into the input would be the hash, and the witness provided is the data, along with all the other layer one stuff that you want to prove. So it's not too expensive to check it, and you get full canonical validation of the layer one without external assumptions, like that there are data split up between nodes and you have to do an attestation check. It's basically, I prove within itself that it's valid and it's deterministic. That sort of thing is maybe not too applicable right now, because first we have to build the ZK systems that could prove entire consensus and do it at scale, connected to Bitcoin, for example, through BitVM and some new proposals they're doing over in the BitVM land. We're not there at the production level yet, but I think that would be the next step in providing whole systemic proofs with data availability, with all the consensus, everything in mind, and make it super secure so that not only can scale, but you can effectively bridge across chains in a much safer way.
That's awesome. That's amazing. There was something that you mentioned that was using external DAs, for example, external rollups. I think that came up in a discussion that you had recently on Twitter as well, right? About the ways to scale and reach consensus. Can you enlighten us a little bit on that as well?
Yeah, so like hybrid approach, right? Like you would want a DA potentially to be at the base, and that would be like the super secure objective DA that has deterministic finality, deterministic guarantees. You running a full node, you don't need to run a super computer or anything. An average node, maybe even a Pi Raspberry device, can sync up and prove within itself that it's following the right chain, and there's no data missing, and everything is valid. There's no slashing requirements, especially with hash-based DA. You don't need slashing requirements because every node gets everything, and you don't need to trust any other node. There's no subjectivity per se. We don't have the option to do that because we're merged mined with Bitcoin, so we can't say that we're proof of stake. We are proof of work. Means no slashing means we need to do hash-based DA. But then if you go down that path, okay, well, you rationalize the design and say this is why it's done, but thinking about it from the big picture, it makes a lot of sense that you want to make sure that whatever you're doing at the base layer, you're not making any trade-offs. You're not rationalizing saying, oh, I need to go to proof of stake now because they need to pump up the DA more. You instead are taking a hard stance and saying you can't do any better than that, because if you tweak any other variables, you're going to lose security. And that's a hard line we can't go past. What's the best we could do with the connection to Bitcoin and the security tied to Bitcoin and proof of work? What's the best you could do? And then the rest of it is going to be, okay, well, people still need higher throughput than that. So how are you going to do that? Well, there are cryptographic, cryptoeconomic solutions like EigenLayer and other Celestia and some of these DA services that offer offloading the DA to another validator set, making those attestations and doing light clients and the smart contract layer to check that, okay, the data exists elsewhere, it's good, but you're trusting another, it's not using the layer one security, it's trusting another service. And that's where you would plug those in as sort of a hybrid approach.
Yeah, sometimes trusting other services, the trust assumptions change drastically because of the way they operate, right? So for Eigen, for example, they are fully based on that slashing mechanism to get more of a financial security than a technical mathematical security per se itself, right? How do you? This is something that I've seen at least some big chunk of the Ethereum ecosystem embrace. How do you see this from the whole Web3 ecosystem, if we even evade Ethereum, and how well accepted do you find that?
So I think the idea of Eigen is pretty cool. Like it started out as let me bootstrap security of Ethereum asset and bring subjective consensus on chain and let you build anything. And now it's morphing into AI agent cloud infrastructure, because with AI, you're going to commoditize software, so you don't need to build any software, but you need cryptoeconomic security still, so you bootstrap that with Ethereum assets. And without slashing, we saw huge demand because there was no slashing, but yet people are making ROI. And so instead of staking, you actually could restake your Ethereum from Lido and restake ETH, put it into an Eigen service and compound your interest without risk. It's just sitting in another contract and you're earning ROI, and you don't even have to be honest as a node operator. And now with slashing, the demand is going to be severely reduced because there's risk and the ROI might not be enough. But the idea behind it makes some sense, right? Because you have an existing asset such as Ethereum that's highly secure, it has slashable guarantees, and it has network effects, and you want to do another blockchain or another service that requires that security, you bootstrap it through the base asset. we think about it this way because, you know, we don't want to, we could say like, look, you have Syscoin there, it's 50 million market cap, not super secure from the perspective of having that same distribution. But how about if we had like a super secure bridge with Bitcoin and it's trust minimized and get the best possible security, and then you apply that asset as the collateral along with Syscoin. You know, have both of them. You have collateralized Bitcoin slashable asset that can earn extra ROI. First of all, yep. Bitcoiners, they don't need 20% ROI. They're happy with 3 to 5%. They're living off their Bitcoin. They're re-borrowing off their Bitcoin and taking just a minimal amount. So 3 to 5% for them covers their borrowing costs almost, because I think now Strike will offer 9% rates, and they're going down up to $1 billion. So you could live off your Bitcoin and pay 9%, earn 40% year over year. It's about 55% growth over the last 10, 12 years. So you have 40% growth, yet there's a 9% cost to borrow off of it. And then you're earning 3 to 5% back or more from a service that might be able to give you ROI with, and if you're honest, with no security risk. So that's how we sort of think about it, is apply, put your Bitcoin to work, create unique services, maybe external DA services, maybe, I don't know, some AI use cases, some DAO use cases that you put your Bitcoin to work and create something else on top. Maybe it's collateralized stablecoins with Bitcoin. You know, this sort of stuff is how we think about it. But like, it doesn't work with wrap Bitcoin today because it doesn't have it has like a trusted centralized entity running it. So no one's going to trust making a decentralized service on top of a centralized asset. You have to have a way to bring in the decentralized asset. And that's the focus point of what Cardano's trying to do, Avalanche trying to do, what Polygon is trying to do, what all the roll-up providers are trying to figure out, is how do we bring Bitcoin in the most decentralized way and then put it to work through the decentralized ethos of Web3. We're close to the Bitcoin side, and we're close to untapping that in the most decentralized way. We put out a white paper 2 weeks ago on how to do that with Sidechain. The problem, you could build Bitcoin roll-ups right on Bitcoin, or you can do through the sidechain, and we argue the sidechain approach is much better, but it comes with the trade-offs, and we eliminate or possibly minimize the trade-offs of using the sidechain with Bitcoin within those bridges.
I see. There is, because when we talk about some of those concepts, like slashing, for example, I can see for such an ecosystem that is all about DeFi, it makes a lot of sense. But I keep wondering if there are difficulties or things that you find the community having a more hard time to digest in itself, for being not so trivial to implement in such established ecosystem, right? As Bitcoin as a whole, like even just the concept of a rollup in itself, as Syscoin acts and operates on top of Bitcoin. How do you see people acceptance of it, and what is the operation like to be able to change the mindset of the people to be able to accept, to digest all this, that it's kind of taken a little bit from the roadmap from Ethereum, right? The decision of scaling through rollups. So how do you
exactly
directing
it's a good question. I mean, even on Twitter today, there was a proposal for CTV plus check stig from Stack, and it's getting a lot of push. A lot of the Blockstream guys, a lot of the core Bitcoin core developers have signed off on the proposal. It just needs someone to create the BIP and be accepted within the community consensus, and the miners, creating the soft fork and the miners accepting it, which I think it'll happen. And check stig from Stack gives us templates and creates the ability to have trustless setups for the BitVM style bridges. It's going to be really cool. Maybe reduce the liquidity requirements, because right now, huge liquidity requirements to run these bridges in a decentralized way. Basically, we have one part of Bitcoin that thinks we need to do a little bit more than store value, and then one part of Bitcoin that is focusing on the Nash equilibrium, utility function, proof of work, just storing assets and having a simple story that doesn't get complicated and no MEV attacks while they're trying to do this stuff, like the Michael Saylors of the world that's running an ETF, basically, that could print money and buy more Bitcoin as long as people keep trusting it. And they their only goal is to hoard Bitcoin. They never want to really do anything with it. At some point, Saylor is going to have, say, 10%, 5-10% of Bitcoin. He's going to be like, what now, right? Like, my investor, I can't really keep buying more Bitcoin. I have to put it to work somewhere. I have to do this in a safe way. There's an economy, hyper Bitcoinization is happening, but I still want to be able to put my Bitcoin into the economy. He'll start creating products. And as soon as you create products, then you have centralization, or you have to do it in a decentralized way. And that's, I think, where we start to come in, right? The other side wants to scale today, wants to do stuff with Bitcoin today. Like I was saying, the people living off Bitcoin, the Jack Millers, he would prefer that because he's going to be paying 9% through his own company to live off his Bitcoin that he has, but he wants to offload that 9% as much as possible in the most trust minimized way. So maybe he takes a little small portion of that, puts it in a premium, risk premium place where maybe there's a little bit more risk, but he's clawing back on that premium he's paying to borrow and live off his Bitcoin. That story still makes sense for them too.
And why do you think people? I mean, I have my personal opinion on that, but what's your take on why would people keep wanting to build on top of Bitcoin instead of going to another environment that is more natively prepared for that? Is it for the security guarantees, for the amount of money that you have invested there already?
So now you're getting philosophical, which is great, but these are philosophical questions. I think many people ask these questions, and I have some interesting thoughts there, and I think they're pretty consistent since I started in the space and started with Bitcoin and all that. I think people don't like to change frequently, right? And there's a first mover advantage. Ethereum, if it had been there first, might have taken over. But I honestly think, like, if you really, really look at it, and you look at it 100 times over from an engineering perspective, proof of work is almost a evolution on top of proof of stake, even though proof of stake came after. If I was designing such a system with taking a look at what Szabo did, and taking a look at what Adam Back created with proof of work, and Hal Finney with some of his ideas, I would have probably started proof of stake first. I would have probably said, okay, I have some rocks. The rocks are not worth anything, but I need these rocks to create a circular economy such that if you do something, I'm going to remove a rock if you do something wrong, right? Now, the rock could have work behind it, or it could be just a rock that's, I don't know, a recent volcanic activity. There's abundance of rocks, and I just use those, right? Or maybe it's from, like, these rocks are just generic rocks, and you don't really care. Right now, the dollar buys those rocks, right? The dollar is what buys those rocks, and you put them into use. So really, it's just dollars being slashed in proof of stake. It's something else. Something else is funding it to create that scarce asset, such that the scarce asset could be slashed. And proof of work is more objective. Proof of work it's an objective cryptographic function that lets you prove that you put work into creating something. It might be a rock, it might be something. It's a logical rock that looks like the same thing as the proof of stake, but you have to prove there was work done, a certain amount of work done, to be able to objectively say, I am qualified to make this function, make this computation, and the whole network validates it. And since it's objective, you don't need to reach out to other nodes to check and harm other people of their financial activities in case they were wrong. So you don't have the whole class of attacks where you're trying to falsely accuse of others, and you don't have the 33 or 40% attacks, which could make people lose money in a false pretense, right? You now have full objective activity where I just need to trust myself. As long as I'm running a node and I trust myself, I will be right and I won't lose money, and I'll always see what the whole world is seeing. It's almost an evolution on top. The problem with the proof of work was first that, proof of stake, it's green, it's proof of work is too dirty and all that. I would say that it incentivizes clean energy creation. The second part was scale, because proof of work takes a long time, and reorganizations and forks take a longer time to hear across the network. Although that's solved now with just sending the headers around with proof of work. It's actually much nicer to hear in a proof of work system than a proof of stake system, because in a proof of work system you could just check the work really quickly and just discard full histories of chains that don't have the same amount of work that you've already seen. So it's much easier and nicer to deal with contention in proof of work. But scale is the real thing, right? You can't really scale proof of work systems to be gazillions of TPS. But we've now learned we don't need that, right? We went modular. The base layers don't need to be super fast. So have your base layer proof of work. It's institutional, it's safe, it's secure. And then you do all the stuff you want to do with proof of stake sort of systems like eigen, slashing, or whatever on top to fill in the gaps at the edges, at the cloud computing layer, at the ZK layers. Yeah. ZK doesn't even need proof of work or proof of stake. It needs a DA service. That's it for consensus.
It's cool. It's cool when you see how the roadmaps from such a different projects in philosophical standpoints, like the way you scale Ethereum ends up bringing solutions to Bitcoin, right?
Yeah. So you have to. I mean, they did a lot of
evolution.
They did a lot of great stuff, right? Like what Vitalik did with the EVM was a big breakthrough, and doing general computing was the Alan Turing moment of our blockchain, right? But the thing is, it's great, and you take these ideas, and it went a different direction, which is awesome. It is what it is, and people love maybe monolithic blockchain. They look at Solana now. They want a modular EVM blockchain that's proof of stake. It's green. You go to Ethereum. If you value proof of work and Bitcoin, and you take the best of the modular approach of Ethereum, you look at us as doing that. So I think it's good to have different takes on this stuff. We strongly feel that proof of work has unique advantages, and the merge mining aspect is not a detriment, it's a big positive, and that's coming to light now. Many of the researchers discarded the idea of merge mining because of selfish mining attacks and all that sort of stuff. But it's now all coming back full circle to a realization that it was the solution, because you can create better bridges with Bitcoin with it.
There is something that you mentioned about being different, and each solution covering different aspects. But in your roadmap in general, I even remember the time we were talking about possible potential integrations and partnerships, like between Cartesi and Syscoin. You had a vision in general that the compatibility between protocols should still happen either way, right? So you still created Syscoin in a way that you were able to communicate with the rest of Web3 as a whole, right? How does that mindset come about, and how do you prepare your ground to be able to connect to everything, at least as well as you can, as well as possible?
Well, in the software, first of all, like before I took a look at any crypto stuff, I had been doing software design for 10 plus years before. Now it's been 20, 25 plus. So you separate the concerns, you create modular components, even within complex systems. If you separate the concerns between how to scale and what are the different leading standards of scaling, or leading standards of how to do computation or how to do consensus, you come to conclusions that you need to tie into some of those, right? Like other people look at it as a bad thing, right? You should have remade your consensus because EVM sucks, right? I took a look at it like, no, I would not spend all the time and resources and wasteful energy on recreating the virtual machine when Solidity exists. It may not be the best, but same thing as when Tim Berners-Lee created the internet, there were many proposals after HTTP that weren't that weren't adopted, but were way better, right? And HTTP won because it got the network effect. So you have to build into the standard. A viewed EVM is that sort of standard that was not going to be replaced. And you don't, again, you just need it to be super safe and secure and reliable, and you build your scale on top. And you don't just need a settlement platform. So we didn't need the virtual machine to be super fast and efficient, parallelizable at the base. So in 2019 or something, we put sort of a blog post out there that showed like how the stacks would look like. It would be like Bitcoin, then you have an SDK layer, you have the consensus layer and security layer of Bitcoin, then you have sort of proof of work and merge mining to connect to sidechain. You have ZK layer as your SDK for computation, optimistic rollups fill in there as well. And then you have the EVM as your programmable sort of settlement layer, and all your use cases on top. Not in that order, but sort of, you have ZK, you have your EVM, you have your Bitcoin, and then you have dApps, and everything else plugs on top programmatically. And if you don't do the standards, you're recreating the wheel, and it's either never going to be secure, you're going to hit a dead end with the market when someone else surpasses you in a modular way, or you will not get adopted because you have to spend so much money buying developers and reteaching them over and over because you are not following the standard, and you didn't even need to follow the standard.
Yeah, this is really cool. I really like the parallel with HTTP, because at some point we wanted better and we were able to build on top of it. So we created like AWS to be able to actually stream data through HTTP mechanisms instead of just reinventing something completely from scratch, which is very, very nice. The other thing I mentioned about, I remember when we were discussing about how Cartesi could be integrated with Syscoin, Rollux was a solution back then that you had, right? And I think if I remember well, Rollux were more on the optimistic side, and now you're having this shift towards ZK. How did that happen in general? What is the gain? What is the difference? What is new? Because I'm not so updated, I guess.
When we did Rollux, we took a look at ZK as well. First of all, again, we didn't want to recreate the wheel. We didn't want to roll our own ZK stack and cryptography. And first of all, we didn't have the resources, nor did we have the experience or expertise. We want to plug in something that works out there. And our unique value proposition is the layer one consensus that we made, not everything. Like, don't expect us to reinvent the wheel and recreate everything. That doesn't make any sense, right? Even like the Bitcoin code, we reuse Bitcoin code. Why would you expect us to rebuild that for any value proposition? We use it in a unique way with merge mining, right? And adding the bridge is a unique value add. So a lot of people have misconceptions that if you're not creating the code from scratch, it has no value. Sometimes the code that's already written could be used in a unique way and create value. That's how we see ourselves, and that value might be much bigger and have long-term effects compared to some code that you've written that doesn't follow, it competes with existing time-tested code out there like Bitcoin and Ethereum EVM stuff, right? So we try to plug in these systems as black boxes, not recreate them. And yeah, that's been our philosophy sort of since day one, is take a look at what's needed to be done. What if you have the standards, follow the standards, but what is missing there? If HTTP was such a generic thing and you can build anything on top, it makes total sense. What is the gaps you need to fill? What is the reason for your existence after HTTP exists or after EVM already exists? For us, we saw a critical gap in the connection to Bitcoin and the connection to all this other stuff happening on the modular side, and there was no tie-in. With some of these Bitcoin layer 2s, you're starting to see some tie-in, but again, like it's very, very early. Like our 2017 research was pointing towards a lot of the stuff that L2s are doing today, trying to scale with a singular roadmap vision, with maybe optimistic or ZK-based designs that create an ecosystem and do points programs, and that's it. And we took a look at that. We thought in 2018, 2019, that was cool. And we did Rollux with optimistic rollups, and we thought of it as like a super chain into Bitcoin. At that time, BitVM wasn't around, so we didn't know of a proper bridge, but we wanted to start with an ecosystem approach. The ZK was not ready at that time. The provers were not open source. The systems were not scalable. It was not going to be user-friendly. 2-second block times with pretty good throughput through our DAs possible on Rollux. And it's been running since. It's been pretty good, but we've always had an eye towards ZK, right? Because it just makes things more secure, removes like the long challenge periods. It's cryptographic and objective rather than optimistic and based on honest challengers, almost like slashing in some ways, right? And it follows more of our philosophy, right? The other thing we get from ZK is you can start to expand horizontally and vertically. Like with optimistic rollups, you could definitely create more chains on top, like what Superchain Optimism is doing. But with ZK, you can go even further. You can create concepts such as shared liquidity. So you can send each other messages atomically and have the whole system roll back if it's not valid because of ZK proofs, right? For example, we call ZK Sys is just a culmination of all the research we've done since the beginning. You have one layer, similar to what ZK Sync and what Polygon wants to do is have like a gateway. And the gateway is a recursive ZK proof settlement layer where all of the chains on top settle in a ZK proofs, and it will combine those and then settle to the base layer and use the base layer as DA. If whatever DA is settling on it, maybe some of them use Validium, some of these volitions, some of them might want to settle in the base layer for full security. So the gateway basically combs through all of that, figures out what data needs to exist on layer one, put the ZK proof on layer one, and it's basically an optimization problem, but also shared liquidity because now every chain on top gets to send each other messages and can be a unique chain, unique ecosystem, but they could share experience with other neighboring chains, almost like a tree-like structure. That's only because of ZK proofs, right? You can do that.
Yeah, me as a fan of fraud-proof solutions and at the same time interop, I find myself in a big impasse because I really like strong computations that are still not able to be completely proved by ZK. So my dream world for like the next 2 weeks, I guess I would say, not 2 weeks, but like for the next few months, would be solutions of interoperability that allows us to have some degree of shared liquidity, so easiness to engage with tokens in multiple ecosystems and multiple protocols, but at the same time, still, I kind of feel the need of for general computation. For example, we have a solution that's Rives, that's a gaming platform. For that, we still need fraud proof to be able to run, to be able to actually validate the computation, right? So I keep having this feeling that
why do you need fraud proofs for that one?
Yeah, we need fraud proofs because the computation is too complex. It's a whole gameplay of a game. You cannot unfortunately just ZK that. But I do feel that more and more I like the idea, the proposition that Vitalik did a long time ago. I don't know if you've seen it. Not that long. It was using a 2 out of 3 possibilities. So it was like using TE, using ZK, and using fraud proofs as fail-safe.
That's for settlement and making sure that some ZK systems might not be secure, like the construction might not be secure, the DA may not be the same. But I think it's more on like if those provers were not safe for some of them, it would be 2 of 3. So you'd have to have 2 provers and maybe optimistic failed assumptions to be able to get a state transition to go through in an invalid way.
Yeah.
So that it makes some sense to have that. It just adds more cost. The thing I find is if you do that, then you also have, if you rely on optimistic assumption, then you fall back to, for Sybil attacks, you fall back
Fair.
to just one of three. And if one of them fails with certain attacks, then they all start to feel the costs of that as well. But you could probably work around some of those things. I think definitely easier to do streaming stuff and high throughput stuff like gaming on top, but that doesn't need shared liquidity for the most part. So you could run those optimistic solutions into the ZK settlement layer and stream it optimistically and settle optimistically, yet that would still connect to the base layer through ZK, right? And you basically don't have any more trust or security assumptions because the system underneath it is ZK anyways, and it's settling that DA to the base layer. So the only thing you really worry about there is pre-confirmations and maybe some unique MEV attacks at the gate, at like the middleware layer, which may not have the same level of sequencing decentralization as the base layer. So maybe some liveness and some MEV attacks related to DA forwarding, but you don't have, it's not too bad, right? It's not that bad. This is another reason why Ethereum wants to, or us as well. As soon as you go into rollups, you need to think about modular or decentralized ways to sequence to inherit the liveness almost at the same level as the Bitcoin mining network. So we have our own sort of sentry nodes that would be involved in creating these based sequencing to create these layers. They make money by sequencing it while providing a valuable service being aligned to the stack to create the liveness and guarantees of uptime on these secondary layers. So yeah, that's how I sort of see that. They could work together. I know you guys did with Dave was pretty good. The Sybil cost there could be covered through the multi-challenge games and the tournament system, which is pretty interesting. That could be used for games and streaming platforms. And then the ZK systems could be used for shared liquidity and scaling the traditional, I guess, heavy computations that require more assurances and maybe finality to be able to leverage cross-chain, cross-liquidity solutions, maybe transfers or real-time payments or those sort of things might be more interesting with ZK.
Yeah, I think it's the same old. There's no bulletproof, right? But how critical do you see being right now in the world that we live this 7-day withdrawal problem, like this pain point?
It's not that bad. It's not that bad. There's also other things, right? Like when you have optimistic, syncing up a node is different than syncing up a ZK proof system, right? Like there is a 7-day, in between the 7-day period, you have to sync the chain and you can have forks in between. You have to have a different strategy. It's more complicated a little bit, like having the optimistic stack worked with that. I saw many of the challenges syncing to those. It's not that bad, but it's still easier on a ZK system to just grab the latest state and sync with any node that has the data. And if it's not consistent with the latest state, you'll know right away. And then doing like a light client is really easy. You have a ZK proof proving recursively that the system is safe. And then having trust minimized bridges becomes way easier. For example, with BitVM2, you're doing a ZK proof of your side system that some event happened, like a burn transaction happened of Bitcoin, and you're moving it back. You can't do that. You're going to have a ZK wrapper around that anyways. So you might as well just have a ZK system and have the ZK proof natively, proving that the burn happened. Right? There's a requirement of ZK within the trust minimized bridge solutions. So you end up going that way either way. But the optimistic games on top that don't rely on the bridging, they definitely should be optimistic because you don't have any of the overhead and you don't have any of the requirements for shared liquidity and stuff like that.
Fair. Fair. It's because at some point you kind of end up mixing the liquidity with the use case, but I think we're still a short time away of that, at least, to be able to do this much. Are there any use cases that you're really excited to see soon?
I think we're at a crazy spot. I think in terms of the interesting retail-based use cases, I think it's going to get crazy because of AI. But from the infrastructure play, I think we're laying sort of the grounds and infrastructure done in a unique way that it's not something that could be ripped up and replaced with the commoditization of software that's happening around with AI, right? That sort of thing, like the Genesis block cannot be reproduced, right? You cannot recreate software that will reproduce the Genesis block of Bitcoin and the network effects of it. So that's how we're sort of seeing this. Is the interesting thing is these realizations we're making of modular roadmap, tying it to Bitcoin, merge mining, creating the bridge, and then the sequencing, decentralized sequencing, and all of the edge chains and shared liquidity, and tying in optimistic rollups with ZK together to do unique use cases. Like the infrastructure of that is really interesting, coming together and seeing that play out together is really cool. The use cases, like for example, stable coins are such a big thing right now. Like 7 out of 8 banks in the US are integrating stable coins as we speak, and worldwide they'll just be settling in stable coins and stuff. So fractionalized or collateralized stable coins based on BTC or hard assets is a real good use case. But again, like as the AI race unfolds, there's going to be all sorts of interesting things that young people come up with. You give them the platform that's secure and safe and scales, and you watch them cook, right? And we don't want to be the guys that are dictating, like, this is what you should build. Like, let them build, but you give them something stable and safe. That's sort of our goal. For us, the interesting stuff is that, right? We make maybe one product distinction, like maybe you make an AI-based system that has wallet functionality and like agents that can talk to each other and you can build together. Maybe you make some cool stuff like that ourselves, but overall, it's best to leave it as a platform and then have people build their concepts inside, because it's a virtual machine.
Yeah. So now I think we have to move on to one of my favorite sessions in the podcast, which is the quick fire. So I'm going to throw at you a bunch of questions, and you're going to answer them with like one word or a small sentence without thinking too much, right? Okay, so you ready?
Mm-hmm.
Okay, so what's your favorite language to program?
I like Python now more than everything else.
What about your favorite protocol that is not Syscoin?
Well, obviously Bitcoin, but you only asked for one, so.
Yeah, exactly. Someone that you think that everyone or every developer should be following right now?
Someone like on Twitter.
Yeah, it can be on Twitter or just someone that people should be following in their lives as a whole and their projects as a whole.
Interesting. Elon.
Sure.
But in crypto, I would say Vitalik is great. I mean, he comes up with good thoughts and actionable thoughts.
What is your best productivity hack?
Vibe coding through Sonnet and Opus right now. It's just next level. I've replaced 100 engineers with one now, like 100x improvement, basically, literally.
Since you mentioned vibe coding, what is the best tool to vibe code right now?
I know Copilot VS Studio is going to integrate natively, but I'm using Cursor, and if you want the best hack right now, you would go buy Claude. You buy a Claude subscription of $200 per month, and then you hook in that to Cursor through CLI, and you integrate the IDE into Cursor. Cursor right now has a little bit of a lead because it shows you the diffs and it's natively tied in, but you don't use Cursor's like chat system. You use the CLI tool of Claude because it understands the code base better, but it can still give you the IDE functionality. Soon, Copilot's going to integrate it. VS Studio is going to integrate it. That everyone's going to be using that. But right now, I use Cursor and Opus, and then if I really need to go crazy, I use Opus with CLI. My costs are probably $6,000 over the last month because I've used it too much. But now I learned there's a subscription of $200 that you could just use the CLI and get probably 5 times better output. So right now, the best of the best is Opus, and it feels like it's coming alive. It feels more intelligent than anything else out there, even more intelligent than other people, other experts. So it feels good, and hooking that into CLI will maximize its productivity for you.
That's awesome, and that's awesome for our rapid fire. But since we're working on vibe coding, I would like to get a little bit of your insights on how well do you think it works? What do you see as how do you see it progressing, and how often do you use it? How much is it? How good is it?
I'm spending all my waking hours on this stuff now, and I'm finding like there's that Justin Timberlake movie about time, right? I'm finding time is the most important thing right now. I can spend 15 minutes doing a pull request to a repo and making like a whole new feature, or I can spend 15 minutes doing something else. So you have to find where to put your time, and your time is worth a lot because the productivity is going through the roof. It's skyrocketing, but it's not just me. Everyone's productivity in the whole world has done 1000x over the last 2-3 months. And now stuff like Opus comes out, the next gen comes out, it's going on a hockey stick curve. We are at a point where we're probably in our last days of software development, I feel. I think we'll end up having like streaming code, streaming UX, like for example, we had a wallet called Poly Wallet. Has bugs all over the place. It's built in React. There's multiple layers linked in. It's complex, large code base, many issues with it. And I'm not a React guy, but it took about 2 years worth of work and crunched it down in about 2 weeks recently. And this is all done in Opus and Sonnet 4, and it just understands. Sonnet 4 is a little bit dumber, but Opus really gets it. It's just so expensive. You're able to get to the expert level of someone that's a React developer without being an expert. You just need to be a software guy. And where we want to take that is basically anything that has a UX, which is almost every product, anything that has software, which is almost everything, hardware, software, everything runs in code. And you're going to have flywheel effects where you basically can have Playwright or something that is able to show the UX and keep recursively going through and solving problems and improving that product to a point where it's just spinning all the time, fixing things, writing tests, fixing things, checking the UX. And you're just going to be like a guy that says, hey, I need Bitcoin functionality in this thing. It goes and adds it, shows you a video, shows you a picture, yes, no. And at some point, you don't even need to do that. Like all UX, all software becomes commoditized, and you as a user get a custom experience to yourself for whatever thing you want to use, whether that's crypto or some other Web 2 thing. It'll just give you that unique experience to you. There's no need for custom development after that. Like I was saying, you can't reproduce Satoshi's Genesis block. You can't reproduce certain things. Those are hard sort of software systems. It's a cryptographic system you can't replace. Everything else is going to be replaceable. Anything that's not based on these cryptographics that have network effects, it's replaceable. So it'll be really interesting to see how it plays out over the next 6 months to a year from there on, because everyone is at this pace, not just me, everyone.
I also feel that there is a double-edged blade in there, in where I see people learning how to code. I have a younger brother that's learning how to code right now, and at the same time, he does so much more than I did when I was in his age.
Mm-hmm.
I keep thinking, how good are the fundamentals now for the person, right? While they're doing it,
It's very weak. It's very weak because it's just like, remember when you first started making games? Like one of my early professors made Stunts, which was the first 3D simulation game before Wolfenstein even came out, and it was 1 million lines of code, and it was mostly in assembly because you only had 256 kilobytes of RAM and a couple of megabytes of hard drive space, and you have to make a 3D game, and so you have to do all the vector graphics and all that in assembly language because it's too slow to do it in C++. And you have to, if you don't understand assembly, you can't make that software. But then now no one talks about assembly because the compiler would do it all for you. So it's going to be like that. Like we're at that point where we still need to have senior people building this, because people need to understand the design patterns. So if he picks up maybe a good book on clean code design patterns, he will maybe be in a better place. It takes 10 years to naturally get there, but you could, if you're a smart guy, higher IQ, you can pick up design patterns and just work within design patterns, because that's all it is, right? It's just patterns. But if you have a senior mentality of sticking to the details, making sure the details are right, making sure the overall design is right, that's good. But you're not going to need that long term, right? Because everything about software is about to change. Like even how we program it, how the design patterns look, it's all going to change. This stuff can basically stream assembly code for us if we wanted to, right? So all the patterns are about to shift, and how we program today, like, you know, all like the loops and functions and classes we make and all this could be flipped on its head and done in a totally different way. When this thing comes, like higher intelligence is coming, and it's going to replace all that.
Yeah, that's actually insane to think about. I'm looking forward to it, but cautiously.
Yeah, I mean, do you have an option, right? You just, yeah, that's why everyone's going crazy, because no one has an option. So everyone's pushing full on. Yeah, it's like if you don't use these tools, you're falling behind. Basically, you're behind everyone else. You need to keep up. But being a senior person, you have an advantage, right? You have an advantage right now. If you keep up, you will stay ahead.
I think it will be harder to be a senior.
Yeah,
and seniors are going to be more looked for at the same time. So
for now,
I think the pyramid will be looking very weird.
Yeah, I think for now the gap is closing though. The gap, like I wasn't a React dev, but I was able to do React development because I'm a general senior guy, right? So I could
exactly.
But the gap is closing, and at some point, you just need the idea person. You don't need the technical experience, but that we're not there yet. But as a senior person, your productivity 100x right now.
Exactly. It's precisely that.
Yeah, I don't know for how much longer, but for now there is that advantage.
Yeah. Well, that was an awesome talk, Jag. Is there any last message you want to send to everyone? Anything that you want to say?
No, I mean, like I really appreciate what you guys are doing, and I know you guys were first with the RISC-V stuff, and it looks like Ethereum is moving that direction. So it validates some of the great work that you guys are working on. I think we were doing an integration before Dave was finalized on Syscoin on Rollux. So with ZKis, we'll look to potentially push some thoughts that way to integrate, because there definitely is a need for optimistic solutions like Rise on top and providing unique experiences. You just can't scale that with ZK today. So I look forward to integrating these approaches.
Throughput will always be a huge problem to solve, and whenever you gain more in one side, you can even gain more in the other side. So I'm still optimistic about optimistic, if that makes sense.
Yeah. No, there's there's definitely a long tail to go through there and find all the efficiency gains we could before the ZK provers become as efficient as they need to be to solve some of those. Yeah, but for us, like for infrastructure, for shared liquidity, for big things, for institutional settlement, it's useful to have a ZK layer. And I can see where Cartesi fits in that picture, though it still has a lot of value within those use cases that need higher.
Oh, for sure. Also programmability, flexibility, and one thousands of other things.
Yeah. No, I look forward to seeing where we take this, because it'll be exciting to see that marriage. We don't have the marriages built in yet, but as you're saying, they're coming, right? Maybe in the next little while, but we can potentially help there and bring these things together, being partners and stuff. I definitely feel there's synergies in connecting the two as much as possible. I think we had some earlier synergies on using ZK as sort of a computational device, but then having sort of a bootstrap into the Cartesi virtual machine, and then having everything else optimistic after that. I think there was some interesting stuff that I think you guys are working on there as well.
Yeah. There are some tweaks. I mean, even Dave will be using ZK inside of fraud proofs. So
nice.
This way you can just verify one tiny step. There are some tricks that you can always do to take the best of both worlds.
Yeah, I think Risk Zero was doing something like that as well. Like we have like ZK proofs as the challenge system. Yeah, it makes a lot of sense.
Exactly. Well, I would love to continue this conversation, but unfortunately, our time is out. Thank you so much for coming. This was really enjoyable, and I built at 4 a.m. Keep building and pioneering the world of Web3. Once again, thank you so much for coming, Jack.
Thanks, guys.